Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Muhammad Izhar Mahendra Surya Nugraha dari kelas pendidikan biologi 2017, jurusan biologi Fakultas MIPA Universitas Negeri Surabaya. Pada kesempatan kali ini, saya akan mendemonstrasikan model pembelajaran menggunakan direct instruction pada materi siklus biogeokimia untuk kelas 10 SMA. Good morning, hello everybody. How are you today? Okay, before we start the lesson today, let's pray together. Finish? Okay, first of all, I would like to check your presence today. So, who is absent today? No one? Okay, good. I hope you are always in a good condition every day, right? So, today we would like to discuss about the biochemical cycle. So, I hope you are able to make the biochemical cycle seems based on the group discussion that we will do today. Okay. Alright, so before we start the discussion today, I have a questions to you. Like, you can give your opinion about this before you're going to discuss it. Does oxygen that we use for breathing every day, it will be stopped producing? Is it possible? You can give your opinion. Maybe some of you think like it's possible, or some of you think that is impossible to happen. So, that's why we are going to learn the biochemical cycles. So when we know the biochemical cycle, you will know about your environment, like what has happened in our environment. Okay. Alright, so maybe some of you start to think like, what is the biogeochemical cycle it is? So the biogeochemical cycle is a pathway by which a chemical substance moves through both biotic and abiotic compartments of the earth. You know, like for the biotic, we call it as a biosphere, and for the abiotic, we know lithosphere, atmosphere, and a hydrosphere. And a cycle is a series of change, which comes back to the starting point and which can be repeated. And the term biogeochemical tells us that the biological, geological, and chemical factors are all involved. The circulation of chemical nutrients like carbon, oxygen, nitrogen, phosphorus, and water, many more, through the biological and physical world are known as biogeochemical cycle. In effect, the element is recycled, although in some cycles there may be places called reservoirs where the element is accumulated or held for a long period of time, such as an ocean or lake for water. Okay, so after I finish the explanation of the definition of the biogeochemical cycles, now let's move to the next lesson. I will explain to you the example of the biogeochemical cycle, which call it as a water cycle. But I have the student's handout to you, so you can check again the definition of the biogeochemical cycle and read all of the definition for each the cycle. Now I will demonstrate to you the water cycle, so pay attention carefully. Okay, now I will explain to you the water cycle. But during I explain the water cycle, you can take a note for the keyword that I explain this. So, water is a common thing in our life, right? I thought that you already know about that. Water can be in the atmosphere, on the land, in the ocean, and even underground. It is recycled over and over through the water cycle. In the cycle, water changes state between liquid, solid, and gas. For the solid, we know it as ice, right? And the gas, we call it as a water vapor. And most water vapor gets into the atmosphere by a process called evaporation. This process turns the water that is at the top of the ocean, rivers, and lakes into water vapor in the atmosphere using energy from the sun. Okay? Water vapor can also form snow and ice through the process of sublimation and can evaporate from plants by a process called transpiration. Did you get from here? Okay. Okay, so the water vapor rises in the atmosphere and cools, forming the tiny water droplets by a process called condensation. Those water droplets make up clouds. If those tiny water droplets combine with each other, they grow larger and eventually become too heavy to stay in the air. Then they fall to the ground as rain, snow, and other types of precipitation. Most of the precipitation that falls become a part of the ocean or parts of the rivers, lakes, and streams that eventually lead to the ocean again. Some of the snow and ice that falls as precipitation stays at the Earth's surface in glaciers and other type of ice. Some of the precipitation seeps to the ground and becomes a part of the groundwater. Okay, so after I finish about explaining the water cycle, now it's your turn to make your own cycle. Based on the student's handout that you get from me, you can mark the keyword from each explanation for the cycle and I will check it. Is it correct or not? Don't worry, I will help you to make the correct cycle. Okay, class, so after I demonstrate it, do you need some help? Or maybe there is something you don't understand about my explanation, or maybe in your student handout? Okay. Let me check your work. So, here it is. Listen me carefully. Like, when you are starting to make the cycle, you have to know the keywords. I mean, keyword is like the important thing that is happen to the cycle. Did you get what I mean? Okay, so I'll give you some example, right? Maybe for the water cycle, you have to know for the water cycle is the water change state, and there is important thing happen to that. You know, the evaporation, the transpiration, precipitation, and the condensation is a keyword of the water cycle. So, when you are starting to draw your cycle, you have to analyze what is happening in the ecosystem. Like, you can make the ocean, and what happened to the ocean? Is that evaporation because the water are getting up to the sky, to the atmosphere? Yeah. And after that, you can analyze what is happened after that. What is happened after the evaporation? So, you can create your own cycle easily. Alright, so to help you understanding the water cycle, I have some video that can help you understanding the material. Let's check this out.
All the water on Earth today, every drop, is all the water there has ever been on the planet. Fresh water is actually millions of years old, the same water flowing in a continuous loop, falling as rain and snow from clouds to the Earth's surface, running in rivers, pooling in ponds, flowing from faucets, irrigating crops, traveling through plants, generating power, eventually evaporating into the air and condensing into clouds again.
Why is there life on Earth? And the reason there's life on Earth is because Earth has this perfect water cycle.
The water cycle. So simple, even small children understand the basics. Yet so complex, the most advanced Earth scientists, hydrologists, geologists, and biogeochemists are studying every part and process.
The water cycle is fascinating. It's something that's around us all the time, and yet we don't really understand it.
How to summarize what is known about the water cycle? With 2 words, flows and stores. The water cycle is a series of flows of water between various water stores or storages. Clouds in the atmosphere,
There's always a little bit of water in the atmosphere. We talk about relative humidity. It's a humid day, it's a dry day. Either way, there's water, sometimes a little, sometimes a lot.
There's a lot of water in the ocean, 70% of all the water on Earth. In the ice sheets and glaciers, 2/3 of all the fresh water on Earth. In the snowpacks atop mountains like the Sierra Nevada. In the Great Lakes. In rivers and streams. In reservoirs and watersheds. In wetlands. In the soil. In and on plants and trees rooted in the soil. And beneath the soil. In water tables and underground aquifers like the Ogallala High Plains, which runs underneath parts of 8 states from South Dakota to Texas. All this storage is temporary. Water in all its forms is always in flux and always moving.
Okay, so after you watch the video, I think it's enough. And I hope you can get the information clearly before we're going to discuss about the other cycles. And okay, now we will going to have the group discussion. So I will give you the students worksheet and you can make a group that consists 3 until 4 students for each group, and then you have to discuss the worksheet and answer the questions at the worksheet. And after that, after you finish the discussion with your friends, you have to present it in front of the class. Alright guys, so before you start to work on your worksheet, the first thing is you have to know the basic competencies and the aims of your work now. So I will explain to you the basic competencies that you have to know. The first is analyzing the components of ecosystem and the interaction among the components. And the second is providing a creation that shows interaction among the ecosystem component. I mean, for this case is the biogeochemical cycle, right? So I hope you are able to make the biogeochemical cycle seems based on the group discussion. So after that, I will explain to you the instruction about the worksheet. Okay, the first is write down the identity of your group in the available column. And the second is work on group to discuss the activities based on the worksheet. Alright, so the third is you are permitted to use the internet, books, or any other literature for searching the answers. But don't forget to note the source below your answers. You can use journals, articles, and many more sources. And if you find the difficulties, you can ask me as your teacher, and I will help you to understand the questions. You ready? Okay, I think you are ready enough to start work. Okay, now let's begin to discuss. Alright, so do you need some help while finishing the worksheet? Okay, so let me help you to understanding the question. There is 2 questions on your worksheet. The first is, based on your group discussion, complete the numbered carbon cycle schemes below. So as you can see, there is a picture that is represent the carbon cycles. And you have to analyze. What is it? What is the components of ecosystem? I mean where is the producent, where's the consumer, and many more. And you have to name the letter below. Okay? And number 2 is, after completing the carbon cycles, this picture, you have to write down the right answer. Okay, the first is write down the biological importance of the carbon cycles. This question is what is the role of carbon cycles to life? And after that, you have to analyze the forms available to life based on the carbon cycles. And the last is you have to identify the major reservoirs of carbon, right? And maybe because you are work in group that consists 3 or 4 students, maybe you can for each students you can do for the 1 questions, so maybe it makes you more fast to answer these questions. Okay, so continue your work. Alright, good job students. So I think most of you are getting understand about the biogeochemical concepts, and especially in this carbon cycle, because I have checked some of your work is, I think it's correct. And now we can end the discussion time because we are moved to the next lesson. Now it's time to present it in front of your classroom. So after you answer the questions on your worksheet for number 1 and number 2, you have to explain it. So I will choose the group randomly, and for the group that I have chosen, you have to explain it to your friends in your class, and I will give you the feedback immediately. Like, you have to explain the answer for the number 1, and after that you have to explain the answer for the number 2. And for each point, for each student, you have to explain it. So I can give you score, and after that, if your friends have some question, you have to answer the question from your friends. And maybe if you need some help, I can give you the feedback immediately, okay? Alright, so let's get started. I think after hearing your explanation, most of your explanation are correct, so good job. Now we are going to discuss the worksheet together. So let's discuss it by step by step for each question. Let's move to the number 1. Alright, so number 1 is, based on your group discussion, complete the numbered carbon cycle schemes below. As you see, there is pictures in number 1. What is that? There's water, there is land, and also there is a building, right? It's a factory? Yeah, maybe. So, let's see. There is 9 points over here. A, B, C, D, E, F, G, H, I. Wow, 9 points. So, what you have to do is to rename it like the process that happens for each point, okay? So, let's start from the A. What is that? A. Yeah, A is atmosphere. But let's see what is that. No, it's not only the atmosphere. It's not the specific answer. The specific answer is the carbon dioxide. Why? Because the A will be processed on the other points, as you see. Alright, so A must be carbon dioxide in the atmosphere, okay? And let's move to the next point. There is B. As you can see, after the arrow this, there is a plants, right? So, as you can see here, B, it must be some process that happens to the plant. What is that? Yeah, it's a photosynthesis. So the plant is used the carbon dioxide from the atmosphere for the photosynthesis process. Okay, let's move to the next point is C. Do you know what is C? Yeah, also C is a photosynthesis. How did you know? Yes, because there is E, like, from the A, it comes to the E. So, there is process that happens to the C. The process is called the photosynthesis. Same with B, because in E, there is a phytoplankton, right? They can do the photosynthesis from the water. Okay, let's move to the next point. There is D. What is D? D is burning of fossil fuels and wood. So the burning of fossil fuels and wood, they can produce the carbon dioxide. So the carbon dioxide will go to the A, or go to the atmosphere. Okay, so D is burning of fossil fuels and wood. That's correct. This building is kind of the factory, right? So let's move to the next point is E. What is E? E is phytoplankton. As I say, like when I explain the sea, E is a phytoplankton as the producent of the ocean, from the ocean, And let's move to the next point. There is F. What is F? Yeah, F is cellular respiration. You know the product of the cellular respiration is a carbon dioxide, right? There is E as a phytoplankton. There also... no. F is from the ocean, is from the fish. Okay? And from the land is from the animal here. So, F is a cellular respiration process that produces the carbon dioxide. And the next point is G. What is G? As you can see, G is there's a wolf and a rabbit. What are they? They are animals, right? So animals are consumers. The rabbit are consume the plants and the wolf is consume the rabbit. So after that they can have the cellular respiration and they have the or have produced the carbon dioxide. And the next is E. Oh no. GH. Yeah, H is the fish. They also the producers because they will produce the carbon dioxide. And the last is E. E is a decompositors or the microorganisms that will decompose any kind of organisms. They also produce the carbon dioxide. So number one is talking about the analyzing the components of ecosystem and the process that happens for each components. Did you get what I mean? Okay, let's move to the next question. Alright, so let's move to the question number 2. So, after completing the carbon cycle above, you have to write down the right answer below. There is 3 questions on number 2 that is have a relationship. Okay, the first is write down the biological importance of carbon. As I say, like the explanation before in the beginning, you have to know the role of the carbon cycle. The first thing. Carbon forms the framework of the organic molecules essential to all organisms. Okay, that is for the point A. Let's move to the point B. Analyze the forms available to life based on the carbon cycle. So, to answer this question, you have to analyze first. What is the forms available to life based on the carbon cycle above? You have to check it out, the picture. Okay, so the answer is the photosynthetic organism utilize the carbon dioxide during the photosynthesis and convert the carbon organic forms that are used by the consumers, including animal, fungi, and heterotrophic protists and prokaryotes on the picture above. Okay, and the last question, identify the major and the largest reservoirs of carbon. Okay, identify the major and the largest reservoirs. There is 2 things that we have to identify, the major reservoirs and the largest reservoirs. So, let's start from the first is the major reservoirs of carbon include fossil fuels, soils, the sediments of aquatic ecosystem, the ocean. I mean for the ocean is like dissolved carbon compounds, you know? Because in the ocean there is oxygen, right, that are produced by the phytoplankton. And also plant and animal biomass and the atmosphere that contains carbon dioxide. Alright, the point number 2 is what is the largest reservoirs? We have to identify the largest reservoirs. What is that? Okay, the largest reservoirs is sedimentary rocks such as limestone. No? However, this pool turns over very slowly. So you have to know, or you have to identify, the important thing is to identify the components for each ecosystem in the picture below, in the picture above, I mean. Okay, that's all from for the questions at the worksheet. Now you can check your score Let's check for the first question, number 1. The maximum score is 45 because there is 9 points here, and for each point you have 5 score. If you are answer it correctly, for each point you have to mark it as a 5 score. Like point A, if you correct, you got 5. Point B, if you correct, you get 5. Until 9, if you 9 point you get correct, you will get 45. Okay? And the question number 2 is the point A. When you are correct, you got the 15 point. For the B, if you are correct, you got 20. And C, if you are correct, you got 20 score. Okay? Let's check you to your worksheet. Okay, so guys, to make you understand about the biogeochemical cycles, I have some short video that can help you understand all of the biogeochemical concept. Let's check this out.
Carbon dioxide, or CO2, is the main greenhouse gas in climate change. So how does CO2 get into our atmosphere? Well, carbon is part of a cycle. It starts with the sun, which hits the Earth's surface with more energy in 1 hour than the whole world uses in a year. Plants, which are kind of like biological chefs, take that sunlight and then suck in some CO2 from the air, mix them together, and bam! They create a stored form of energy in the form of carbohydrates, such as glucose and sucrose. The process is called photosynthesis. When animals like us eat those plants, our stomachs convert that food back into energy for our own growth. Greenhouse gases are a byproduct of this process and are released through waste. If those plants die, they decompose, and tiny microorganisms break down those carbohydrates and again release greenhouse gases as a byproduct. As you see, energy originates from the sun and is then transferred as it moves through the food chain. But sometimes, carbon-based organisms, like plants or animals, get stuck in the earth. When this happens, they're compressed under tons of pressure and turned into carbon-based fossil fuels like oil, coal, or natural gas. Since the Industrial Revolution, humans have been pulling those fossil fuels out of the ground and burning them, activating the stored energy to make electricity and power engines. But the thing is, it also releases millions of years worth of stored CO2 back into the air. In addition, humans breathe in oxygen and breathe out CO2, but plants do the opposite. Trees suck up huge amounts of CO2, which balances the cycle. Thus, deforestation reduces the plants that store CO2. We're attacking the cycle from both sides. Think of it like a computer. A computer can operate a few programs at a time, right? Normally, when you've finished with the document, you save and you close it, so as not to overwork the computer. Then, imagine you stopped closing your documents, so they were all open at once. Your computer wouldn't be able to process it all. It would start to slow down, and then to freeze, and eventually it would crash, which might be where our environment is heading if we keep overloading the carbon cycle. So, is there any way to rebalance the ecosystem? What about technology? Technology is defined as a technique to solve a problem. And so, sustainable technologies are those whose output is equal to their input. They do not create negative externalities, such as CO2, in the present or the future. They sort of cancel themselves out to solve the problem. To achieve this, we need to invent sustainable technologies. If we put all the ideas and technologies ever created into one circle, then invention is the pushing of the boundaries of that circle. And the area outside of the circle is infinite, meaning the potential for invention is limitless. Think about some of the incredible clean technologies we have today. All those ideas have one thing in common. They all came from people. People innovate. People create. It's the limitless potential of creative people to build unimagined technologies that is going to stop climate change and rebalance the ecosystem. And that is something to be hopeful about.
Alright, so I think it's enough for the video. Now let us conclude the lesson today. So, we are studying about the biogeochemical cycles. Let me remind you again. The biogeochemical cycle is a pathway by which a chemical substance moves through both biotic, or we know it as a biosphere, and abiotic, or we know it as a lithosphere, atmosphere, and the hydrosphere compartments of the Earth. Because the biotic and abiotic is a component of ecosystem in our Earth, right? Yeah. And a cycle is a series of change, which comes back to the starting point and which can be repeated. So let's move to my question at the beginning of today's lesson, like how does the oxygen that we use for breathing it will be stop producing? It is possible or not? So the answer is it's impossible, right? Because Earth have the system like we call it as a biogeochemical cycle. So the oxygens will be not stop producing. Okay? And the term biogeochemical tells us that biological, geological, and chemical factors in this Earth are all involved. Yeah, the circulation of chemical nutrients like carbon, oxygen, nitrogen, and many kind of compounds through the biological and physical world are known as biogeochemical cycles. That is the biogeochemical cycles. So I hope you can understand the material today. Okay, so I think it's enough about today's explanation to the biogeochemical cycle. Now, I have some kind of announcement to you for the next meeting. I have a project to you, but you have to work in individual. And what is the project? The project is you have to design your own biogeochemical cycle using the software of computer, right? You have to design for 3 biogeochemical cycles. That is the phosphorus cycle, the nitrogen cycle, and the water cycle. You have to design it beautiful and simple as the information to the audience, because next meeting you have to present it to all of your friends and I will check it. If you need some help, you can ask me, okay? So, I think it's enough for today activity. Thank you very much for your attention. I hope you can understand about the biogeochemical cycle and stay in the good condition, because yeah, I hope to see you again for the next meeting and I hope you can do your project very well. Okay? That's all from me. Before we end today's learning, let's pray together. Praying start. Amen. Finish? Okay, see you guys. I hope we can meet for the next meeting. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.